Hello everybody and welcome. Today we're going to go over types in C++ and let's get started. Bool. Let's get right into this. So bool is basically something that is, true or false value. So if I did bool x equals false, um, it could just print out x here and it would print out 0 because false prints out as 0 whereas true prints out as 1. And now this is how you assign a variable. So you just put its type and then you put its name and then you put equals and then you assign its value. So there's that. Next we have a string, which is a set of characters. I very briefly went over this in the last tutorial. So string x equals I love to eat human beings, because why not? Alright, so love to eat human beings. Printed that out very quickly, very easily. And let's go over the next type. So int x equals 28,103. So let's build this and run it. Boom. Pretty easy. And now I'm gonna go over an example with integers. You can have negatives for them, assuming they're signed, and they're automatically signed, so you don't really have to worry about it. Um, so you could still have a negative int. You don't have to specify it's signed, but if you have an unsigned int and you set it to a negative value, you're kind of just going to get the number. You're going to get 2 to the 20. You're going to get 2 to the 32nd minus the absolute value of the negative value, I guess you could say. So, yeah, because I would go over the technical part of it in the binary, but basically what it does is there's a sign bit at the first bit of the number, like the leftmost bit. And if you have an unsigned int, that is reserved for the actual number itself, because in essence all of these numbers are binary. And a binary system is the two powers of numbers. If you don't know what it is, you can search it up, I guess. But so yeah, it would overflow into that because it's unsigned. So if you turn on the bit that says it's signed, I guess, or if you turn on the signed bit by means of putting a negative, it's going to turn that bit on, and then it's going to be really high number. I think that's how it goes. It's a very bad explanation. And that's where it gets its name from, the signed bit. And with signed ints, you can obviously, have negatives. So anyways, I kind of went over that too long. Next, there is floats. And one thing about the ints and some of the other number values I'll go over, they do not allow decimals, whereas floats, doubles, and long doubles, which I really probably won't be using long doubles, do. So floats can be 0.01. They are 7 digits in precision. So this would print out 0. Oh. Well, it gives you an E minus thing, but I think there's a way to undo that, but for this, actually, I'm just gonna do 5 point because I'm too lazy to fix that. So do 5 point. Wait, yeah, no, actually, I'm stupid. That was. Wait, does it do 5? Does it do 5 digits in precision? I think I might be a bit misinformed here, but I'm pretty sure it is a lot more precise than the well, no, it's a lot less precise than the double. Sorry, I need to fix this. It is actually, let's go to the float. It is 5 digits of precision. But I think that actually might depend on your compiler, because when I searched it up, just to clarify, because I always search up my information for clarification purposes, it said 7, but that was the Microsoft thing, so it might have just been the Microsoft Visual C++, but there's that. So anyways, the next thing we have is a double, and let's put I said that Okay, okay, whatever. So let's put 15 digits, and then that might also be inaccurate. So let's do that. 15 zeros. Okay, 14 zeros. That'll be about 15 digits thereafter. Okay, 14. um 13. I don't know. I really should have tried this actually. I kind of feel bad now for showing this on the tutorial. But yeah, I think there might actually be another problem. I think it might be with the see out thing, so I apologize. That probably they were actually right. But the thing I said about the compilers is still probably true. Probably it depends on your compiler, but then again, I might be incorrect there, so I apologize for that. Really should have done a little bit more testing, but anyways, so the long double, it's essentially just a double with more precision. We won't really need to go over that, but here's the long. It's a 64-bit integer, which is like our int, but it can go to even higher values. And if I didn't already tell you, ints can go from these two values, so up to 2 to the 31st power. And if you tried to make it go above that, it would just overflow, and yeah, it would go back to the negative, and if it was unsigned, it would just go back to 0, I think. I don't know. I really don't feel like giving too much of an explanation, but just remember to stay in those general guidelines. These are the max, these are the minimum. And this all assumes it's signed, so it could be to the 64th if it's unsigned. And short, well, it's up to the 15th bytes, even less than that. I really suggest you use bytes if you don't really want to store that big of a number. But generally, I don't really care. I just always use ints because that's just what I feel like doing. And now for enums, whatever you want to call them. I think enumerables. I think that's the longer name. But anyways, these allow for several different values of something. Like you could have a bool. It's like a bool in the sense that it could only be true or false. Have things other than that. Yeah, but yada yada yada. We won't really be going over enums more. We will later, but this is kind of going a little bit ahead. And char, uh, short for characters, indexes. So basically, this creates a character with as many indexes as you want. There's multiple ways to define one. So char 5 equals hello. Well, actually, since 5 characters. Oh, I'm stupid. Unexpected qualified. Oh, sorry. I was making a really stupid mistake right there. There we go. How is that too long? It's supposed to be 6. There we go. Sorry. So, yeah, I had to do a little bit of fixing this. It's like become a habit for me to put this in the type. But really that's just for the value. So, anyways, what this does is, well, it creates a character with 6 indexes in it max, and since there's 5 characters in here, you have to put the characters plus 1 for how many characters you can have in here. And you could also put this at, like, say 100 and give it more than it really needs to have, I guess. And you could also put this as, I believe you can also put it as just blank, and yeah, it worked like that. And there's also another way to define them. So just do this. H E L L O /0, which terminates it. And we can make them infinitely long unless you set an index right here for how long. And this kind of begins to go over arrays, which we might go over in the next episode. I really want to do the basic parts, or at least what I consider essential basic parts, quick. So anyways, hello, and boom. I'm very highly sure that the /0 is required. Yeah, you don't really want this coming out of the string, because the /0 terminates it. And we'll go more over the escape sequences, which I'm pretty sure that's what these are called, in a later tutorial. And I just want to test something. I'm not sure if this will work or not, but I never really tried this. Um, yeah, so you can't have double quotes, I don't think. And of course you have to end it off. So anyways, and one more thing, I think I actually thought of a cool program to make because of the character, and not terminating it and getting the end result and all that stuff. That would actually be pretty cool for a generator thing. But anyways, that is it for this episode. I hope you guys, if you guys didn't enjoy it, just like the video. If you guys threw a lemon at your computer, just I don't know. Um, I don't know. Eventually, you'll use this stuff later in life, or you might make a program, or you might I don't do whatever the hell you want with this information. I don't know, dude. Like just throw a toaster at something. Goodbye.